Switch this to brush instead of pen. Yes. 100 decimals. I believe your lives will forever be changed today based on what we're going to talk about. So when you go home and your parents ask you what happened to you today, you can say, well, we had just this great talk about rational numbers. This is the preface with this. Okay, we have in our world of numbers, we have what are called rational numbers, and we have what are obviously irrational numbers. Are two R's in irrational? I think there are. Okay, and the strict math definition, the exact math definition of this is for something to be irrational. For something to be irrational. Irrational numbers are decimals that are non-repeating and non-terminating. Okay. A decimal that does not repeat and does not end. Okay, which would, an example of that is, the best example we give is pi. If you look at pi, which is up there, you know, it goes out, I don't know, there's probably what, maybe 30 or 40 or whatever decimal numbers. And there is nowhere that pi repeats in a pattern, and those little 3 dots at the end, but mean it goes on forever. So pi is irrational. It doesn't make sense to us because in reality, it's not an exact number. Okay, it's a decimal that goes on forever. Okay. In addition to that, other irrational numbers we have are square roots of numbers that don't work out evenly. For example, the square root of 2. If you were to punch that into a calculator, it would go out as far as the calculator will allow it to, but it still keeps on going forever. They don't repeat. Now, what that has to do with today is we are talking about rational numbers, but we're looking at the specific rational numbers that are repeaters, and they are ones that terminate. And the reason that these are rational numbers is because every number that repeats and every number that ends can be made a fraction. You can make a fraction out of, or come from a fraction. We probably won't make fractions, but we'll realize that they come from fractions. Okay? For example, let's start with the easiest part. Decimals that terminate, let's say I've got 0.35. Okay, that's a terminating decimal because it ends. And you can make that a fraction easily by doing what to it? How do you say that number? It is 35 what? Hundredths. So that's the fraction that it is. It's 35 hundredths. And of course you reduce it or whatever, what, 7 over 20 or whatever it is. Even if you had this, 0.0635. I can make that a fraction because it is what? It is 635 what?
Thousands.
It is not thousands, unfortunately. It is tens, hundreds, thousands, 10,000s. It's 635 10,000s. And you can reduce that, but I'm not worried about that. But what we really are focusing on today is this. The fractions that become repeaters. And you're familiar with a few of them. Somebody want to give me one?
1/3.
Yeah. The fraction 1/3 is what repeating decimal? Well, and you only have to do up until where it starts to repeat, and you put a line over what repeats. 1/3 equals that. You've got, I think I gave you the list again, right? 2/3 is 0.6 repeater. Other ones that repeat are, well, 1/11. Well, let's do the ninths. We got the ninths, right? 5/9 is an easy repeater because it is 0.5. And you put the little those are all. 1/11th, by the way, what decimal is 1/11th? Anybody know? Probably not. And if you don't know, guess what? No, it's not irrational. Any number that is or starts out as a fraction will always be rational. Okay? Will always be, because that's what the exact definition of a rational number is, any number that you can make a fraction out of. That's the exact definition. And any repeater and any terminator can be made a fraction. If you don't know what 1/11th is, you'd have to do it out as 11 divided by 1, or 1 divided by 11, sorry. And you get, well, 11 doesn't go into 10, but it goes into 100 9 times. You get 99, and you get 100 again, which is, you're just going to keep getting this. So 1/11th is, as a repeater, 0.09 repeater. Okay. Now, here comes the part that most people struggle with. All repeaters you can also make fractions out of, or I mean percents out of. For example, let's do this. Repeaters, 2%. Because people get a little wigged out and confused on this. If I have 1/3 as a fraction and 0.3 as a repeater, what percent is that? What percent is that? What percent is 1/3? You could look on your little fraction circles if you kept them, but I don't. We have to get past those and figure out how they actually came up with that. 1/3 as a percent is what, Logan?
33 1/3.
33 1/3%. How do I get that out of what I got here? Well, you probably want to do it with this. Take a look, see. If you remember what we do to decimals to get them to percents is you move the decimal 2 places. So that's where the 33% comes from. Okay, where does the 1/3 come from this? Well, if I have a decimal of 0.3 repeater, what is it? It is 1/3. Or if it's 2/3, which is my 0.6 repeater, what percent is 2/3? David?
66 and 2/5.
Correct. Really, whatever this fraction is that started out being is going to be the same fraction that's in your percent after you do those 2 things there. If you had 7/9, what percent would 7/9 be? Knowing that 7/9 is 0.7 repeater as a decimal, what percent would that be? Move the decimal over 2 places, Cameron English, and it's what? Mia Schwartz? Exactly. Move it over 2 places, it's 77, and whatever this fraction is here, it's 77 7/9%. Now, I'll really test you on this one. How about this one? 1/11th. 1/11th, which I said was 0.0, and then the 9 repeated. What percent would that be? Move the decimal over 2 places. Ryan, you end up with?
9 and 1/11%.
Exactly, 9 and 1/11%. 9 and 1/11%. You see what else they asked you there. I was gonna see if you could change percentages back, but I don't think they asked you that. Okay, that's gonna be good for that. Now take out another blank piece of paper. Forever changing your lines one more time here.